As we're starting into the mathematics of juggling, one of the very first things we have to start talking about is how to describe patterns. Because descriptions are very important. One of the things is, suppose we want to communicate with people. If we're all learning to juggle in our own individual way, we might come up with different terms. Like we might say, well, it's a purple elephant with a backward somersault at the end. And of course, to you, that might make sense. But to someone else, they're like, huh? But the other thing, of course, in addition to being able to communicate what you're doing, is the ability to explore the possibilities. So we need to have a way of description that allows us for easy communication together with the ability to do exploration. Now you might say, well, communication is super easy for juggling. We'll just record a video of us juggling and we'll send it to our friends and all is good. Well, yeah, now. But what if we didn't have that technology? What if we just had something where we could only write down some very short form and that was all we had? Maybe a few symbols. Can we communicate juggling in that way? The answer is yes. So how do we do it? Well, let's think about it. So imagine, if you will, that you have a juggler who is just walking around and as they're thinking about juggling. Now, for some beginning jugglers, this is not so unusual. When they begin to juggle, there's a tendency to throw the ball a little bit forward. And soon you find yourself chasing after the ball. Well, now you're not juggling, you're joggling. But still, okay, suppose that we're walking. And as we walk along, we can keep track of what happens with the balls. Well, let's try to do a little bit of a visualization here. So let's think about it. Suppose here we have our juggler, and they're going to go along, and we're going to keep track of the balls. And what happens? Well, as time moves forward, the balls move up and down, but it will more or less look like this for the most basic 3-ball pattern that people juggle. And now we're like, aha, we can see what's happening. We can keep track of every individual ball. And now we can see how it all fits together. So in some sense, this is capturing the behavior of the juggling pattern. And we've marked here little beats. So these are, the ball comes in, and we think to ourselves, the ball comes in, and we throw it back again. Automatically, boom, boom. And of course, there's a little bit, in reality, you have to hold it for a small bit of time, but we're trying to just sort of give a very simplified, very abstract idea of what's going on. So this diagram here, we can use to describe the patterns. Now we're going to, of course, improve on that, but we want to talk about what are these diagrams and how do we use them. So these are called juggling diagrams. Well, of course, juggling, because that's what we're doing, diagrams, because we're keeping track of what's going on. And again, we're following the path of the balls. Now, there's some basic assumptions that we're making here. One is that we throw forward. In other words, we're not going to throw the ball backwards in times. We believe in the arrow of time. We can only throw the ball forward in time. So that's a fairly reasonable assumption to make. Another is that our balls are going to land on the beats. So in other words, we're not going to have a ball land at time 3.141592. No. 3 or 4. No time in between. This is the discrete nature of juggling. So the balls only land on the beats. We'll think of the beats as being on the integers. We're also only going to have at most one ball per time. And the last thing is we're going to focus on things which are periodic. Now, some of these assumptions are going to be pretty hard and fast. Other assumptions we can relax over time. So which ones are we going to stick to always, and which ones are we going to be able to relax as we go on? Well, the first two, the fact that we throw forward and that the ball lands on the beats, those will always be there. But the second two, over time, we'll learn how to relax. Now, one thing that we might have is this assumption, one ball at a time. Well, there's something called multiplex. In multiplex juggling, you're allowed to catch multiple objects. That's where the multiplex comes from, at the same time. So maybe 2 or 3 balls can come in and 2 or 3 balls can go out. Now, the other thing that we might relax is periodic. For right now, we're only going to focus on periodic patterns, And then as we go further on, as we start to explore the space of patterns themselves, not just the patterns, but the space of patterns, then we'll start to say, oh, okay, now we can be more flexible and we can start to move around. We have freedom. Now you might notice something here. We say at most 1 ball per time. Well, that gives a possibility of 0 balls. How do we represent that? Well, there's generally speaking 2 ways you can represent that. Now, one way you can represent a 0 throw is just to say, look, at that beat, nothing happens, nothing comes in, nothing comes out. Sometimes you'll see a different version, which is, okay, what happens is that you have nothing comes in, nothing comes out, but we still want to represent something happening, so you might see a loop. And I've heard it described as a ball and an anti-ball come together and they cancel each other out, and there you get the 0 throw. Now, I will tend to be biased towards this convention, but of course, there's arguments to be made for either convention. So that's juggling diagrams. So we're getting close. We now have a great way to communicate what's going on, but we want to be able to go one step further. So our one step is what we call siteswaps. Siteswap is a term in juggling, and oftentimes if you talk to a juggler and you say, hey, let's talk math or juggling, and they're going to go, siteswaps, right? Well, kind of. But what happens is that siteswaps are a way of describing the patterns, which take us from the diagrams to a nice set of numbers. All right, well, what are siteswaps? Well, it actually is very simple. It answers the following question. I have a ball, because you're juggling. A ball comes into your hand. What should I do with it? In other words, how should I throw it to keep the pattern going? So what we can do is we can say, okay, what we'll do is count how many beats in the future that it lands. So the ball comes in, and it's going to be thrown and land in the future. How many beats? Tick, 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 until it comes back down. That's what siteswaps are recording. It's recording our throws. How far are we making the throws? And here, far being time. So let's look at some very simple patterns. The first pattern we'll look at is the 3-ball cascade. And it looks something like this. It's the very first pattern that many people learn to juggle, which involves 3 balls. Well, all right, what's going on? So what we'll do is we'll just come along and we'll record what's happening here. So we start and we just follow the ball and say how many beats in the future is that? 1, 2, 3. All right, next one. Okay, lands here. 1, 2, 3. Okay, how about the next one? 1, 2, 3. Now you might notice that, in fact, something's happening here. With every one that we record, it's always 3, 3, 3, 3. And so that's what's happening here. It's always 3 beats in the future that the balls will land. All right, so there we go. There's our siteswap. So we can say, aha, there's our pattern. So the 3-ball cascade is going to be the pattern, or the siteswap, if you will, of 3. Good. Now you might say, wait, 3? How did that happen? Well, we don't want to write down 3, 3, 3, 3, 3, 3, 3 infinitely often, because one of the things that's happening here is because in our diagrams we're assuming it's periodic, as a result, it goes on forever. And so we're not going to write down infinitely many 3s. We don't have enough paper. What we'll write down is okay, what's our building block? All right, in other words, what's the part that if we repeat it over and over again, it builds out the whole thing? And what we can see is, well, it's always a 3. So as long as we just repeat that 3 over and over, that will get us to where we're at. Another way to think about what's happening visually is we're saying, okay, we're just going to take one piece here, and if we just copy that over and over, then we'll see the whole pattern emerge. Now at this point you might say, I don't think that's quite right. Wait a second. The colors aren't matching here, right? The colors coming in the left are slightly offset from the colors coming in on the right. Now, here's the thing. When we talk about juggling diagrams, we really don't care about the colors of the tracks usually. We could. That adds an extra condition, and later on we'll talk about what happens when we do. So if we ignore the colors, it's perfectly fine. Now, what if we wanted to include, says, no, I really want to have the colors on that left-hand side matching the colors on that right-hand side. Okay, we could do that. So one way we could do it is if instead of taking a single block of just one time step, we take a block of 3 time steps, then it's perfectly going to line up and everything works out. So one thing we could say is that the 3-ball cascade is 3, or of course we could also say it's 3, 3, 3, or we could say it's 3, 3, 3, 3, 3. Any number of 3s, that'll produce the same 3-ball cascade. Now, which is the correct one? And the answer is yes. Well, they're both correct. It just is a matter of saying which one do you want based off of your assumptions, and there's arguments to be made in many directions. Okay, well, let's try another one. Okay, suppose we look at this second one right here. That's different. You can see that there's things happening here. Some throws are very small and some throws are very large. There's other things that are happening. For example, here, you see this small throw? It's completely contained in this larger throw, which means that there's a ball that's going to be thrown, and while that's up in the air, a ball will be caught, thrown, and caught again. This has a term called nesting. We'll come back and talk about nesting on another day. So what does this correspond to? Well, this is the shower, and it would look something like this, where you have balls going up higher, and then, of course, there's a ball being very low at the bottom. It's a very easy thing to animate, so oftentimes if you look at animated cartoons, if they have people juggling, they tend to juggle in that sort of circular pattern there. Okay, well, let's talk siteswap. So what do? Well, we do what we did before. So here we just count number of beats. 1 beat, see, that's that throw very quick. All right, and then what? Well, this is very far in the future. That's at 1, 2, 3, 4, 5. Okay, how about here? 1. Okay, another big one. 1, 2, 3, 4, 5. And 1. And again, big one. 1, 2, 3, 4, 5. And we can see a pattern is emerging. This is what's called 1, 5, 1, 5, 1, 5. And so we have that the 3-ball shower also has a very nice description in terms of numbers. We can say, okay, it's 1, 5. Now, you might say, wait a second, why 1, 5? How about 5, 1? Well, both are perfectly fine. See, that's the nice thing about being periodic. It's really, in some sense, it's cyclic. So we can choose where to start our window of what we're looking at. So it's true that we could look at something where it starts with the 1, 5, but we could have alternatively looked at something which is 5, 1. Both of them are describing the same pattern. So again, there are multiple siteswaps which can be used to describe the same pattern and really describe the same juggling diagram. Because when we talk about the juggling diagram, we don't actually have these numbered. I don't know where time 0 is or time 100 is. I just know that these are where the beats are, so that you could shift it as you need. All right, well, one more, right? Already, just with these 2 examples, the 3-ball cascade, 3-ball shower, we start to see that there are interesting things going on. That there isn't just one juggling pattern, that there are many patterns out there. Now, what's our last juggling pattern? Well, it's going to be this one right here. I won't tell you the name yet, but let's see if we can do a quick example. So I have some balls here. A little bit chaotic, but something like that. All right, so what is it? It seems weird because one of the things that's different, you might have noticed if you're paying attention, is that one of the balls at some point went straight up and back to the same hand. These other patterns, they didn't do that. They always went between the hands. So here we have balls that went to the same hand. All right, well, to figure out what's going on, let's run the numbers. So we'll start here. Okay, it's going to land where? 1, 2, 3, 4. Okay, how about the next one? All right, comes here. 1, 2, 3, 4. And then 1. Okay, how about here? 1, 2, 3, 4. Okay, here. And that's going to land over there. 1, 2, 3, 4. Okay, how about here? 1. All right, here. That's a nice big one. 1, 2, 3, 4. Okay, here. 1, 2, 3, 4. And you might notice, we're getting the same numbers. And in fact, those numbers will continue to repeat. Okay, so the throws are 4, 4, 1. Now, here we can pause and say, 4, that must have been those throws that are high that went to the same hand. The 1 we've seen before, that's a quick throw across. Indeed, in siteswap, we can start to describe the throws. So a 1 is a quick throw, hand to hand. A 2 is a throw, and in 2 beats you'd be back to the same hand, right? Because we tend to alternate left, right, left, right. So a 2 is actually represented this way. You just hold on to it. A 3 is between the hands. So 3 beats, tick, 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 tick. A 4, well, to land 4 beats in the future, you'd have it go straight up and back to the same hand. So that's where a 4 is. And of course, you can get numbers arbitrarily large. Mathematically speaking, there's no reason why we couldn't have gigantic numbers involved in our siteswap. Practically speaking, we run into troubles. Okay, so we talked about there's a 3-ball cascade. We talked about there's a 3-ball shower. Now there's this pattern. So what is this pattern called? Well, this pattern has a nice name, and it is called 441. That's the name. So why 441? Isn't there like the 3-ball whirligig or something? Like, no, because this is one of the patterns that mathematicians were able to discover, but jugglers didn't know about until they had that ability to explore the space of patterns. Now, of course, we can describe it in multiple ways. There's 441, or you could say 414, or you could say 144. They're all the same, just depending upon where you start your block. And so, this is wonderful. We have lots of different patterns, and we've only just begun. There's going to be infinitely many patterns in some sense, and we want to be able to start exploring that. But now with siteswap, we have a nice compressed notation. You give us a juggling diagram, we can write down the sequence of throws, and we can say, aha, here's the siteswap that corresponds to this particular set of throws, and now we have a descriptor. So we can, given a juggling diagram, figure out the siteswap, but we can also go in the opposite direction. If we have a sequence of numbers, which is a siteswap, we can make the diagram, and it's pretty straightforward. So let's try it. Okay, so here we have draw juggling diagrams for 5304 and 733. All right, let's start with 5304. Okay, that's going to repeat in steps 4. So we're going to draw our line. Here's our number line. We mark our points, and we'll give ourselves plenty of points so we can make sure we capture the whole diagram. And what we do is we say, okay, how does this work? Well, what's going to happen is these record our throws, and they repeat. So it's going to be a 5, 3, 0, 4, 5, 3, 0, 4, 5, 3, 0, 4, and you just keep writing, so forth and so on. Okay, so let's begin. So 5, that's going to land 1, 2, 3, 4, 5. 5 beats in the future. So I need to get to the 3. Here we go. And how about the 3? 1, 2, 3. All right. How about the 0? Well, that means that no ball came in. A 0 is an indication no ball landed. All right, so we won't draw anything there. Okay, 4. That has to land 1, 2, 3, 4 beats in the future. All right. And we're back to the 5. 1, 2, 3, 4, 5. Okay, that's going to land over here on the 3. The 3, 1, 2, 3. 3 beats in the future. The 0, nothing happens. The 4 goes 4 beats in the future. And we continue. The 5 goes 5 beats in the future. The 3 goes 3 beats in the future. We don't draw the 0, and so forth, and so on. And so now we can start to see the pattern, at least in terms of the diagram, about what's happening. So there's throws over here, and then there's throws over there. So there we go. That's the juggling diagram that corresponds to that site swap. That's beautiful. And of course, if we wanted to see it, we could learn it. There's also wonderful tools online that allow us to enter in a pattern, and then it will demonstrate what the pattern looks like for us. So in other words, it'll actually do the juggling so you can see, that's pretty. That's nice. Okay, so that one wasn't so bad. Now, what's the other one? 7, 3, 3. All right, so start similar way. We draw our line, add lots of points on our line. So these are our beats that we're drawing here. Beats by juggling. So, okay, so 7, 3, 3. 7, 3, 3. 7, 3, 3. And let's see what happens. So this is how we go. So 7, whoa, that's a long ways in the future, right? That's okay. That's all right. Jugglers are very patient. You know, one of the basic ideas of juggling is that when we think about juggling, the patterns are continuing forever in all directions, forwards and backwards. So 7, where is that? 1, 2, 3, 4, 5, 6, 7. All right, so there we go, the 7. Okay, how about 3? 1, 2, 3. That's not so bad. How about this 3? 1, 2, 3. That's not so bad. All right, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so that's way over there. Okay, 3. 1, 2, 3. All right. And, whoop, wait. Uh-oh. Do you see something? Something terrible has happened here. Look. What do you see? Well, there's this ball that was thrown a while back. Woo! And then this ball that was thrown a little bit more recently, and they're coming in at the same time. That shouldn't happen. One of our assumptions is that there's only one ball at a time. So this is a collision. So in other words, what we have is 2 balls coming at the same time. They're going to collide, which means this pattern can't be juggled. Because one of our assumptions is we're only going to be able to handle 1 ball at a time. So that is not a valid site swap. Now, this might make you a little bit nervous, and it hopefully should. Because what does that mean? Well, it means, look, just because I have a sequence of throws, it doesn't mean I have a valid pattern. Because it's possible that eventually, and it might take a while, but eventually, I'll get some collision happening. So what do we need to do? One of the things that we have to figure out is how can we test to make sure no collisions ever happen? Now, of course, one thing we could do is draw out far enough and convince ourselves, look, nothing's collided, and we could keep going forever, and we'd be good. That's not so bad. But of course, what if our throws are very large? We'd have to draw quite a lot. So what we'd like to do is find a shorthand way of saying, okay, will there be any problems with this pattern or not? And so we're going to figure out a nice way to answer that question. When you're trying to learn a pattern, you might say, whoa, I'm struggling. But why am I struggling? Am I struggling because it's difficult, or am I struggling because it's impossible? At the beginning, you really can't tell because they both feel the same. And so one of the things we like to do is to be able to say, hey, this is possible. And of course, once we know it's possible, it's like, okay, keep working. We'll get there. We'll get there. Keep in mind that these juggling diagrams are indeed a simplification. So while they are describing the pattern, there are some things that you can do to slightly change the way that the juggling is done. So for instance, you might have a throw called an in throw versus an out throw. And by taking different combinations of things, you can get different effects, all which correspond to the same juggling diagram. So for example, the juggling diagram we've just been talking about corresponds to all the following. So you have what's called the 3-ball cascade, the reverse 3-ball cascade. You can do a half shower. You can also do something called tennis. And all of these patterns are really the same in terms of the juggling diagram. So we haven't completely described all of the artistry inside of juggling, or put another way, there's still lots of things that juggling allows us to add for flourish. Now, so far, we've really talked about siteswap. That's one way to describe what's happening. Of course, there are other ways to think about juggling and other ways to describe patterns, and we'll get into some of them as we go further on. Now, one of the things that we can do right now is to sort of have a bit of a thought experiment. What would it mean to juggle in a zero-gravity environment? Now, there are some things that you can do. There's things which are called bounce juggling, where you take your ball and you bounce it, and then it comes back up because it hits the ground. Now, that you can do in a zero-gravity environment. But of course, if you do traditional juggling and you throw the ball, well, then you might say, whoop, okay, anytime now. it's not going to come back down. All right. So what can be done? Well, the challenge is that the balls don't return. And so we can change our perspective. See, right now when we juggle, we think of our hands being fixed and the balls are what move. But why? We could also say, look, let's have the balls be fixed, and certainly we can just have the balls stay in place. And now our hands can move. So our hands can move between the balls and say, okay, at the right beat, this is the ball we should hit. So we should hit the green ball or the yellow ball or the red ball, however many colors we have. And then we're still doing the same pattern, but with a different perspective. Instead of saying, let's look at it from the perspective of the balls moving around, let's think about it as the hands moving around. So how would we start to describe things in that way? Well, one thing we can do is you can say, well, let's think of the balls as having colors. So we can go back to our diagram that we had before, and we can say, all right, well, look, let's just mark down the colors. So here's a yellow, a red, a green, a yellow, a red, a green, and so forth, and so on. So what we can do is now we can say, look, this is the pattern that goes yellow, red, green, yellow, red, green, yellow, red, green, yellow, red, green. All right, great. So what we can do is we can think about what's going on here. We can think of our balls. Here we have our yellow ball, our red ball, and our green ball, and we can move our hand. That's a little bit of our beat here. So it's yellow, red, green, yellow, red, green, yellow, red, green, yellow, red, green, right? And that's our pattern. Very simple pattern. We just go around, we repeat every 3, everything gets hit once. That's our 3-ball cascade. How about our 3-ball shower? How did that work? Well, if you think about what the picture was for the juggling diagram, there was that quick throw, right? So what happened is that if you had a ball and you did the quick throw, you'd have it again, and then you do a long throw. And so because you did doom, doom, you'd see that hit twice in a row, and that would repeat. Okay, so it looks something like this. Bum, 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 bum. There you go. How about 4-4-1? That one's really a lot more interesting. So I won't go through the logic. You can draw the juggling diagram. So for 4-4-1, it would look something along the lines of the following. Bum, 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 bum. 2 beats, 1 beat, 2 beats, 1 beat, 2 beats, 1 beat, and you just cycle around. That's 4-4-1. And of course, you can imagine lots of different possibilities, lots and lots of different possibilities. And so, lo and behold, we have a way to describe patterns in a different way. And you should say, hey, this feels a lot like we're drumming. It is like we're drumming. So you could describe these drumming patterns in the same way that you're describing juggling patterns. So this sort of shows you, hey, things are highly flexible. The mathematics that we're developing to describe juggling are not limited just to juggling. They can be used to describe other things as well. So in particular, they can be used to describe anything which is periodic and repetitive. So if you look around, you start to notice, oh, there's other things where this applies. So keep your eyes open. The world is full of interesting behavior. All right, now we have some ways to describe patterns. Now we can start to answer some questions. Our next question we're going to tackle, and that'll be coming up, will be, how do we know that a pattern will be juggable? And how many balls will it take if we have our site swap? Great questions, and we'll talk about those in the near future.